All right, ladies and gentlemen, we are on page 17 of your packets. So if you are not on page 17, find page 17 of your packets, complete this warm-up. Pause the video. When you are done with the warm-up, come back and see how you did. All right, so hopefully you solved this one. You would have distributed the -2. Make sure you're following with the negatives. This would be -2x. And then I need to follow through with the negative over here. Make sure you're paying attention to the fact that that was a -4. -2 times a -4 is a positive 8. The answer is -2x plus 8. The answer to this one, I'm going to take the -3 and distribute it over here. So I'm going to have -3 times x. This next one I need to distribute here. That's a +1. Negative times a positive is a negative. That is then going to give me a -3. Combining like terms down at the bottom. To combine the like terms down at the bottom, I'm going to spend time putting my shapes around it. Please take advantage of showing your work and drawing the shapes. You are less likely to get something wrong when you do that. I would have put circles around my like terms, put boxes around my other like terms, put triangles or clouds or something around the other like terms, just to know that they go together. These are all positive, so they're going to give me 7y. This box is a -2. That is a +9. So I follow my flow chart. Yes, it's adding. No, the signs are different, so I subtract, and I'm going to take the sign of the larger one, which would be positive. So then that's going to give me a +7. And these two, when I subtract them, I'm going to get a +1x. Again, the order doesn't matter. So some of you may have put it in 1x plus 7y plus 7, and that is just fine as well. You can do that. All right, so again, you are on page 17 of your packet. I'd like you to pause the video and take a minute to read those 4 vocabulary words. All right, now that you are back, the vocabulary words are as follows. Variable. Variable is a letter used to represent a value in a mathematical expression or equation. What we need to know is that it is a letter representing a number. Verbal expression. Verbal expression, what I want you to do in your notes, and pause the video if you have to, but I want you to highlight or box or put a star around or underline the word word, because verbal expressions are written in words. Verbal expressions are written in words. Next, we have a numerical expression. A numerical expression is an expression that has only numbers and operations. So just like in the last example, I want you to underline either numbers or underline or box it or star it or highlight it, but you need to underline numbers as well as operation, because the only thing that's part of a numerical, which almost looks like the word number, are numbers. An algebraic expression, the difference between numeric and algebraic is that this will contain variables. So if it has a variable, it's algebraic. If it does not have a variable, it is numerical. Notice all of these have the word expression. I would like you to pause and go back to page, I believe it's 5. Go back to page 5. Nope, I am way off. Go back to page 9 and look at the word expression to know what expression means. All right, hopefully when you went back for expression, you found that expression is not having an equal sign. There is not an equal sign. It's just letters put together. Here are some examples. So at the bottom of page 17, I want you to write these examples down for what is verbal and what is numerical. Notice that all of the numerical problems only have numbers, and the algebraic problems have letters. Please hit pause and copy these down. All right, then what we have are some words to represent what is addition and subtraction. You know these, but I do want you to copy them down. So you're going to turn to page 18 in your packet. And when you turn to page 18, you're going to see spots to fill these in. Hit pause, fill these in. Hit pause and fill these in. Don't worry about that. That was for a different class. All right. Then down below, we have some example problems. We have these word phrases. This first word phrase are all of the same ways to say x plus 9. I could say 9 more than a number. I could say the sum of a number and 9, a number plus 9, a number increased by 9, or the total of x and 9. Those are all different ways to say adding 9. I'm going to skip down here for a second, and we're going to go to this one. 6 multiplied by g, 6 times a number, a product of g and 6. These are all the same way to say 6 times g. Then I have another set here. A number divided by 5, the quotient of t and 5, divide a number and 5. Here's what you need to know. You have graduated to middle school. And by graduating to middle school, we don't use the dot line dot anymore. We're going to write it as a fraction. And as we go through and do some examples, you're going to see why it's important to do that, especially with order of operations. I'm going to go back up here. What I'd like you to do is read through these 5 different explanations and write down what you think it would be, because some of you are going to be surprised when I reveal the answer. Okay, if you could pause, if you didn't have a chance to read it, pause it and finish reading them, but I'm going to reveal the answer. A lot of people look at this one a little bit differently, and they put 4 minus h, especially for this example here. And this example here, you got to be careful. When I'm looking at that, this is 4 less than a number. In order to take 4 less than a number, I need to know what is that number first. And then I can subtract 4 from it. So please be very careful when dealing with the subtraction problems, because if you're going to get something wrong, 90% of the time, that's where it comes from. I would like you to hit pause and on your paper try to solve these 3, and then when you're done, unpause it and see if you got it correct. So for this first one, when you had solved it after you hit pause, you should have had 5 plus d. It is possible to do d plus 5 because of the commutative property. However, it doesn't work for all the problems. Here, if you don't know what the product is, go back to the top of that page and you would, where we wrote all the different types of words down, and you would see product means to multiply. When I multiply, I'm going to write it as 5g. I am not going to write it as 5xg because that means something different now that we're in middle school in algebra. The next one you had was 11 fewer than a number. This is one of those problems that is subtraction, so you need to slow down and think about it. If I want to take 11 fewer than a number, I need to know what is that number first. So I need to start with f and then take away 11. I need to know what that number is first. These are not in your packet. They are on the screen. So what I would like you to do is hit pause and solve these in some extra space there on your packet and in the margin, and then come back. For this first one, again, because it's referencing subtracting and it's saying less than, I need to start with the h, and then I'm going to subtract the 17. Quotient means to divide, and when I divide, I'm going to divide in order that it reads. So I'm going to read this as 20 divided by t, because it's in the order that I read it. The next few examples that I have here are not in your packet, but I encourage you, please do not skip over them, because it is very important for your homework that you see some of these extra examples. Okay, when I am reading these examples, I just need to be careful and work slowly, because you may miss something. I'm going to read it once all the way through and then come back and go piece by piece. 4 multiplied by the cube of t is reduced by 5. So there's a few things I know. The cube of t. Cube means to the third power. So this is really t to the third power. Reduced by means I'm going to subtract somehow. And multiply means I'm going to multiply. So this says 4 multiplied by the cube of t. So I want to take 4 and multiply it by the cube of t. And that this is reduced by. Reduced means to subtract. So I'm going to reduce it by 5. This one wasn't terribly confusing other than the cube and what that stands for, but you still need to work slowly to make sure that you are fully understanding. The next one, the sum of 10 and twice the square of j. So this is where we need to pay attention to what it is asking. The sum means the answer to an addition problem. So it's telling me I have an addition problem and I'm adding something to get the sum. What am I adding? I'm adding 10 and twice the square of j. So 10 goes here, and I'm combining that with twice. Twice means I multiply by 2. The square of j means j squared. So then I'm just going to take this and I'm going to drop it down into my spot. So the answer to this would be 10 plus 2j squared. I should have put that squared a little higher, but I think you were paying attention as I wrote it. All right, let's look at a few more. 2 divides the difference between 8 and r raised to the 4th power. There's a lot going on there. So first of all, what I read is that 2 divides the difference. 2 divides the difference, so I need a difference. The difference would go on top because that is going to be divided by 2. The difference will be divided by 2. What am I finding the difference? Well, I'm finding the difference between 8 and r raised to the 4th power. So r raised to the 4th power looks like this, and I want to find the difference of 8 and that. So 8 minus that. That is the difference that I had to find, and that whole thing is being divided by 2. All right, let's look here. The square of b added to 6. That's pretty easy. The square of b, so I need b squared, and I'm going to add that to 6. Again, the commutative property says it doesn't matter the order for this one, but according to the verbiage, it is telling me that I am taking the b and I'm adding it to the 6. Again, if these are moving too fast, hit the pause button. That's what the beauty of video learning is. The next one, the cube of f is subtracted from the 2/9. So let's just get rid of this the, because from 2/9. The cube of f is subtracted from the 2/9. So I'm going to put 2/9 here, and I'm going to take the cube of f and subtract it from this. To find the cube of f, I just write f cubed. All right. This next one, again, is a little bit tricky, and you just have to slow down as you read it. The cube of the total. So this is telling me that at first I need to have a total of some kind. The total is of x and 2. We said that total would stand for adding. So I need this total first, and once I find it, I'm going to cube it. It's very important to take the time to read these through once or twice and then go back and try to write the problem out. When we evaluate expressions, this is in your notes, it's at the bottom of page 18. When we evaluate these expressions, this goes back to the beginning where we take some values and we plug it in. At the bottom of your page, you do not have m, r, or t written in. I ask that you take a minute, plug these in. If you're pretty confident you know what you're doing, I want you to pause this video, solve those problems, and come back and see how you did. If you're unsure, watch the first example and then pause it and complete them and come back. And if you're really not sure, then just watch as I work through all of them. All right, pause the video now if you're going to try it on your own. Okay, so in this case, when I have a 5 and an m right next to each other, they are multiplying. So I know that this is the same thing as 5 times m, but I know m is a negative 7. And then I drag down the minus 6. According to order of operations, I have to do my multiplication first. So I'm going to have 5 times negative 7, which is negative 35. And then I need to subtract 6. According to my flow chart that was on the side of the wall, the first thing I need to do is see if they are adding. If they are adding, then I'm good to go. If they're not adding, I need to make it tick-tock somehow. So I'm going to tick-tock. Now that they're adding, I'm going to look and see, yep, the signs are the same. And if the signs are the same, I just add them together and keep the sign. 35 plus 6 is 41. Keep the sign, it's negative. I'm not going to work this slowly through all of them, but make sure that you are taking the time to write out your steps. It'll be helpful. In my next problem, I have 4 times m plus t. So this is going to be 4 times negative 7 plus t, which is negative 2. This is multiplying, so I need to do that first according to order of operations. So it's going to be negative 28 plus a negative 2. And then I just add those together to get negative 30, and that is my final answer. If we go down to this next problem, we have r divided by t. We know that r is 8. We know that t is negative 2. I know that a positive divided by a negative is a negative, and 8 divided by 2 is 4. You may use a calculator for these, by the way. M times t. M is negative 7. T is negative 2. And when I multiply them together, I get a positive 14. At this point, what I would like you to do is go show the substitute teacher your work for problems, these last 4 problems. If you do not have your work shown, you need to go back and show your work. Once your work is shown, bring it up to the substitute and grab the worksheet. But pause this video because I'm going to go over a few examples from your worksheet after this. So, if you didn't show your work, go back and show your work. If you did show your work, go show the sub your packet and she will give you the worksheet that you need to complete as homework for tomorrow. Here are some of the examples from your homework. There are 2 sides to your homework. One side has about 32 problems. The other side has only 24 problems. I am working on the side that has only 24 problems. So please look at that side as we go through it. This first problem here is from it's the very first problem on your page. It reads, 4 times the sum of x and 2. 4 times the sum. So right now, this is telling me 4 times the sum that I need to take 4 and multiply it by a sum, which means I need a sum, and a sum is an adding problem. So I need to get an adding problem and take 4 times that. Well, what am I adding? If I finish reading it, it says 4 times the sum of x and 2. So my sum is x and 2. The parentheses are critical because if you were to write this, this says something different. This says 4 times x increased by 2. It does not say that. So you need to slow down and make sure that you have the parentheses in your problem. I am not doing all the problems on this worksheet. I'm just touching base on a few. So run down to question number 3. If you want to try it by yourself, go ahead and hit pause. See if you got it right. Otherwise, I'm going to walk through it for everybody else. All right, this is telling me 60 divided by the sum of n and 2. So I'm taking 60 and I'm dividing it by a sum. Well, what is the sum? It's the sum means the answer to an adding problem. What am I adding? N and 2. So I need to take 60 and I'm going to divide it by the sum of n plus 2. This is one of the reasons it's very important to graduate from the dot line dot to the fraction bar. Because if you were to write this, 60 divided by n plus 2, according to order of operations, you would have to do this first. And that's not what this question is asking. It wants you to do the sum first. So make sure you graduate to this, because this would be wrong. Skipping on down to question number 8, and I believe I'm going to verify. Nope, I did have one more. Skipping down to question number 8, you need to find the difference between x and 3. This one is fairly simple, so if you want to pause, try, and come back, go ahead and do that. All right, so the difference between x and 3, again, difference means to subtract. What am I subtracting? X and 3, that's how simple this one is. You're done. All right, last but not least, number 17. As always, hit pause if you want to try it on your own and come back. Okay, here we go. 9 less than the sum of 4 and x. 9 less than the sum. So I need to take 9, and I need to know the sum. And I need to take 9 less than that sum. So here's my sum, and I need to subtract 9 from it because I want 9 less than the sum. What is the sum? It's the sum of 4 and x. The sum of 4 and x. Now, technically, due to order of operations, this would be fine, but it would be much better if you include the parentheses to help me know that I need to take that sum first before I subtract it by 9. Your job is twofold. What you need to do for me is make sure that yesterday's assignment is in the basket, turn-in basket up front. Yesterday's assignment is in the turn-in basket up front. Make sure your name is on it. Then you need to complete this worksheet. It is due tomorrow. If you are done with both of those activities, yesterday's homework and today's, if you owe me any other missing work, please start and work on that. I have many people who are missing pages 419 from day 1, day 2, and day 3. And if you're not sure what the homework problems are, go to page 5 in your packet, and that's where the homework log is. Go to page 5 in your packet. Okay? Oh. Your homework then is that worksheet. Sorry, we didn't do the word problems today. We're going to do those another day. Your homework today then is the worksheet. You're going to work on that worksheet. When you're done with that and you have missing work, make sure you work on those. Look at page 5 in your packet to see what homework problems they were for the assignments that you missed. Then, if you are done with all of that, on the side wall where the clock hangs, there is a red hanging file folder, and inside of it are different little number games. I want you to grab one of those and work on it, or read a book. Find something to do to remain quiet so other people can get their homework done. Thank you. Hope you have a great rest of your Tuesday, and I will see you guys tomorrow.